All right, so it was a perfect setup to follow my two colleagues. Thanks a lot. I guess I made the opposite choice. I told to tell you something very specific that we've done in our work that was built on mathematics and how it came about. And I'm really going to give you the quick introduction, and I'm happy to drill down anywhere you want in the discussions. So this is a group, Greg Hirschlag is one of my main collaborators, and a whole group of people at Duke. So it really started around 2013 for me with an undergraduate project, I should say that in this crowd, an undergraduate research project. And we really ended up setting our question to try to understand what gerrymandering was. And there were a lot of things that people said to me and said around me. One, people always want to make comparisons to what the statewide vote count is. So I'm thinking about splitting up our state into congressional districts. So I live in a swing state. I live in North Carolina. We have 13 congressional districts. You'll see in a minute, we're a very purple state. And how there was an election that 50% basically voted Democrat, and there were 10 Republicans out of 13 elected. And people immediately said, that's not fair. That's a travesty of justice. And they said it should have clearly been 7-6 for the Democrats, because that was close to proportional representation. But the fact is, we don't live in a proportional representation system. We just don't. That's not what we have. We have some idea of protecting minorities. We have some idea about the land getting a vote, right? Geographically localized districts. Another thing people often say is, if your districts look funny, they must be gerrymandered. Well, I can tell you that in 2016 and 2012, we had two districtings in North Carolina. I'll show you in a minute. One looks completely crazy. One looks really beautiful, and politically they're identical. And so I put up this definition that I pulled off some website, some dictionary website long ago that I don't remember. I should probably remind myself. And I put two words in red. It says to manipulate the boundaries of districts to favor one party or another, or to change the outcome of an election. And both of these seem to suppose that you know what the outcome should have been, and it was somehow different than you expected. And that's what people are trying to do when they argue about proportional representation, or they argue about wasted votes or partisan symmetry or some idea up there, some abstraction. And we really wanted to take a very kind of hands-on perspective, something let the data and let the state speak for itself. And so, oops, there we go. So we wanted to answer ask the question, what would have happened if we had no political agenda? And so I'll just throw in that this work we've used has, as the introduction said, it's been used in a number of court cases. And the good news is that in 2020, North Carolina will use different congressional maps, different state legislature maps for both our state house and our state senate that were based on court cases that had a number of mathematicians testifying in them, including myself. And so you can also, one of them went to the Supreme Court. The Supreme Court decided that they were not up for that our Constitution didn't protect fair voting. Turns out that the North Carolina Constitution says that elections should be fair, which the US Constitution doesn't. And so they went back to the state court, and the state court ruled that they were unconstitutional. So we have 3 new maps because of court cases largely involving mathematicians and political scientists, I should say. It was a team effort. So here's the kind of picture that Hannah was showing you. And I'll say that I live in a state that I'm lucky. We have good data in North Carolina, maybe until the Republicans started trying to subvert it recently. But historically, we've always had bipartisan good data. So until I started trying to do other states, I had no idea how lucky I was that my first attempt had been in North Carolina and the data was good, or else I might have given up quickly. So here's a precinct level map of the state of North Carolina. These are little precincts, and these are the 12 congressional districts that we used in 2016, all right, in the 2016 elections. These were eventually deemed unconstitutional, but here's the precinct by precinct voting. So this is percentage Democrat or Republican vote. Red is Republican, blue is Democrat. First thing you might notice, 2 things. Well, one thing right here is even the precincts get denser where there's lots of population. So my state is very heterogeneous from a population point of view. There's dense places and rural places and mountains here. This is the Appalachian Mountains. These are islands out here. You go, here's the voting, and the voting, yes, it's more blue in the cities, but it's also very blue in some of the less populated areas. It's not so simple and clean. And there was this real question in my mind of, just like Massachusetts, could you ever draw a district out here that wouldn't end up Republican, right? It's just the state of where people live. And so that really interacts. And so we wanted to understand that question. So let me play a little mind experiment for us. So here, let's first of all figure out who wins. I've taken up those votes and I've added them up in each district. And here's who was elected. So there were 10 Republicans elected and 3 Democrats. This was actual historical data. That's what happened. And you can see there was just a slightly Republican election. These little people down here are us, the people voting. Now let's take the exact same districts and let's change them. So if you notice quickly, I'll flip back and forth to let you see how they change. So I'm changing to another redistricting. I never change a single vote. People just change where the lines are. And this is actually from the 538 website. And this is one they designed to be as friendly to Democrats as they could. So not surprisingly, when I do this and elect people, here we go. There you go. So now we end up electing, I'm not very good at math. Mathematicians don't add very well. So let's see, I think there's 8 Democrats being elected and 5 Republicans. So just what I'm trying to tell you is that by changing where the lines are drawn, you can go from 10 Republicans elected to 5 Republicans elected. I mean, that's a dramatic change. And somehow we have this idea that people go and vote, and then their vote is interpreted by our districts, and we get some idea of the political signal sent by the will of my state to Washington, right? And what I'm showing you is I can flip the headline completely. I can flip it from landslide Republican victory to landslide Democratic victory, you know, Republican agenda validated to Democratic agenda validated just by redrawing the lines. Now we can have a conversation about people voting for people, but I think Professor Gelman might be able to argue that people vote somewhat party often lately, but maybe not. We'll see. So here are 4 maps, 4 historical maps. The first ones with actual years are actual maps. The 2012 map, the 2016 map, the 2020 map. You might look at these two and think they're very similar. In fact, these 2 maps are very similar. And then this was a map that was done by a bipartisan redistricting process, a simulation. Some retired judges, half Republican, half Democrats, who were tired of gerrymandering, got together to kind of show what it would look like. Tom Ross at the Volcker Alliance for Better Government ran this project. And this kind of gives you a baseline of what it might look like. And now let me just show you what we did. So we drew thousands and thousands of maps using mathematics, using software, but they were all based on kind of nonpartisan criteria. They were not like that 538 map. They were based on things in the law and things in the legal practices of my state, the Voting Rights Act, preserving counties, preserving municipalities, preserving equal population, as Professor Gelman already mentioned, within reason, trying to make the districts relatively compact like they've been historically. And what we see now is we have a histogram, which shows the number of Democrats elected along the bottom and the number of times that happened, the percentage that happened in our ensemble of thousands and thousands of maps. And so this somehow uses the actual truth of our state, my state, North Carolina, and where the people live. He's using this essentially kind of a scientific investigation of what the laws interacting with the geometry of our state and where the people live would produce. I'm not saying this is what should have happened. We only have 1 map. We have 1 election, but here's a set of actual data, an actual spatial pattern of how people voted. And these are the outcomes. And what you see is that the maps we used for almost a decade in North Carolina, the purple and the orange, are really unusual maps. And so that was convincing to the court that these were atypical. And maybe even more convincing that was the following thing. So let me show you a simulation from this. So what I'm doing is I'm using something called partisan swing to take an actual set of votes and shift it up and down. We do more than that, but this is a nice demonstration. What it shows you is that this enacted map barely ever changes. It's more or less stuck, right? So you see up at the top, I'll show it to you one more time. Here's the statewide vote percentage right here. And you notice that this enacted map for a long time never moves, even though this ensemble of maps, this collection of maps we created, shifts to the right as the Democratic vote. It's responsive, right? Election has consequences. When the people change their mind, different number of representatives are elected. But this enacted map is almost set up as a firewall to protect against that. Let me show you another example. This is from another case. We actually showed this in court. When you think about how to explain things, Professor Gelman could have been reading from my crib notes before this, when he said, I don't like mathematical intimidation. I don't like it when someone says, here's a number, it's good, trust me, here's my CV. I like to have ways of explaining things to people and then let them make their own decisions, right? You know, science at its best is a microscope, which you can invite someone to look through and then they can draw their own conclusions based on what they see, right? Highlight. So here, what we were trying to do, we showed this to the court. This is our house, state house in our legislature, 120 seats. We're going to play the exact same game. We're going to take a set of actual votes. This was when President Trump was elected. It starts at 48%. And then we're going to slowly shift it. And as it shifts, the histogram of our ensemble is going to move to the right. And the yellow is the map that was drawn after the court proceedings, that the court forced. And the purple arrow is the map that was drawn out. And the lines that might be interesting to keep an eye on are these dotted lines. These represent the supermajority. This side, the Republicans have a supermajority. This side, the Democrats have a supermajority. And this is when the control of the legislature flips. And what I want to claim is that whether they're meant to or not, whether it was just by their own intuition, they basically designed a map that kept the supermajority from being broken and then the majority from flipping for as long as possible. So right now it looks very good. It's very typical. It's right in the middle of this histogram. And as it moves to the right, we're going to see it slowly change. Sorry, I seem to be having my computer's slowing down. I don't know why. So there it goes. So you see the overturn map gets stuck there behind, and now here comes, it's really lagging quite a far bit behind, right? It's really stuck there. And if I use this was actually a very friendly map. This is an unexpected election. If I use a different election, it would actually be stuck much farther over to the left, right? So, you know, it's only right now that it finally breaks the majority. So it really lags behind. It really seems to have this effect. I won't go into this slide much. I'll just say that this is done with a bunch of mathematics. We think about Markov chain Monte Carlo sampling. If you've taken a math class or statistics class on Bayesian sampling, maybe Professor Gelman's, and you know, you can read his book about how to do this. We use some of his tests to assess the convergence of our chains. And you know, so there's first this idea of turning law into math, then using mathematics sample, and then finding a good way to explain it. I won't go into all this unless people want me to. But I'll just say that there's a whole bunch of these same ideas can be applied to a lot of questions. You know, how will we critique the maps that are gone in the 2020 census? The Princeton Gerrymandering project is doing a really good job of getting data ready. You know, how can we raise the level of discussion that really brings in ideas that explain what's going on, not just kind of, you know, talking head points on you know, Meet the Nation or something, if people even listen to that anymore. How do we empower journalists? So I've been talking a lot with journalists in North Carolina so that they can do their own analyses, so they don't have to rely on me, so that they can be in a position where they can ask their own questions and ask their answers. But they need scientists to help them learn how to do that. You know, what will the effects on the changes of the census? How will differential privacy, how will different things like that affect all this? How do we better design a redistricting process? That's now coming up now. You know, it's not just writing down a bunch of rules. I promise you, every time you write down a bunch of rules, someone will find a way around it. I think we have to develop some procedures where scientists help make things open and transparent so people can see what's going on. And last, how do we help states make better decisions? And there you go. That's all I have to say. Thanks a lot for inviting us.